Hey guys, it's me. Hope everyone is doing well. I wanted to continue on with these notes that we started in our last class, our last virtual class. This is our strategy number 3 that we want to look at, and it's basically just getting common denominators of things or looking at things in terms of a common denominator. In this example, we can recognize that 1 over cosine theta plus sine theta over cosine theta can be split into its common denominator parts. So that's pretty straightforward, just separating things into its common denominator. So 1 over cosine is secant theta, sine over cosine is tangent theta, and that does equal secant theta tangent theta. So that works out just fine. Same thing here. This would be 1 over sine theta plus cosine theta over sine theta equals cosecant theta plus cotan theta. And as you can see here, this is cosecant theta, this is cotangent theta, and this equals cosecant theta plus cotangent theta. So that works out. So these are just like proofs from geometry, and that's kind of what you want to think about. You want to make one side equal to the other side. All right, so strategy number 4 is combining two terms into one. So this would mean actually getting a common denominator because we don't have one. So if I rewrite this problem, and think about what do I need to make a common denominator, this guy needs a cosine x over cosine x, and this guy needs a 1 plus sine x over 1 plus sine x. And then we're trying to get that all equaling this. When we do that, we end up with cosine squared x plus 1 plus sine x times 1 plus sine x that we're going to need to FOIL over cosine x times 1 plus sine x. And I'm going to go ahead and leave that in factored form. I'm going to go ahead and FOIL here. So I end up with cosine squared x plus 1 plus sine x plus sine x plus sine squared x. All right, I know that cosine squared x and sine squared x, and this is just the numerator part. All right, I know that cosine squared x plus sine squared x is 1. So I end up with 1 plus 1 plus 2 sine x all over cosine x times 1 plus sine x. And we're trying to get that to equal 2 secant x. 1 plus 1 is 2, so I've got 2 plus 2 sine x over cosine x times 1 plus sine x equals 2 secant x. Notice in the top I can factor out a 2, so I've got 1 plus sine x over cosine x and 1 plus sine x. This is a long proof. My 1 plus sine x's cancel, so I just have 2 over cosine x equals 2 secant x, and luckily that works out. All right, so it's just a lot of, I'm going to not do this one just because we ran out of room and it's the exact same problem, just with the reciprocals. But going back to the beginning, just multiply each side by what it needs, FOIL, combine like terms and look for identities, combine and look for identities. Down here I factored out the GCF, and then here I canceled. So you're just looking for things that you can do, and then hopefully you get to the end result. In our strategy number 5, it is just to look for Pythagorean identities. And if we go back to that, and remember, if we forget what the other ones are, we can divide by sine squared x here, sine squared x here, sine squared x here, and we get 1 plus cotangent squared x equals cosecant squared x. Here, if we divide by cosine squared x, we end up with tangent squared x plus 1 equals secant squared x. So these are our 3 identities that we can use. And you want to remember those. Because looking in this very first example down here, we have 1 plus tangent squared x. And that happens to be, I'm rewriting the first part of that problem, secant squared x. So that's cosine squared x times 1 over cosine squared x, and that does equal 1. So we're just looking for things like that. Same thing in the second example. 1 plus cotangent squared is cosecant squared x, and we've got sine squared x. And we know that cosecant is 1 over sine squared, and that is just 1 equals 1 as well. All right, so not too terribly bad. Couple ways we could do this next identity. At some point, you just kind of have to put everything together. We could look at cosecant squared t as cosecant t, because there's 2 of them. And then 1 over cotangent is tangent. So we're looking for, does that work? So I replaced the 1 over cotangent with cotangent. So cosecant is 1 over sine t, 1 over sine t, and this is sine over cosine t. Forgot all my t's, sorry. All right, so one of these cancels, and I'm left with 1 over sine t times 1 over cosine t. And I want to know, does that equal cosecant t, secant t? And it does. This is cosecant t, secant t equals cosecant t, secant t. Okay, so just looking to convert things into sine and cosine, look for your different rules and see what you can do. I'm going to not worry about strategy number 6 right now. We'll worry about that at another point. But overall, we're going to do some practice. I'm going to post the homework and just have you do some more practice with these. But follow these steps. Convert to sine and cosine. I should say follow these options. These are all options. You can factor. You can look for identities. You can get a common denominator. So if all else fails, try one of these options and see if that can help you. So I'm going to give you some more practice. Hope you guys are doing well. I sure do miss you, and hopefully I'll talk to you soon. Bye.